Subtract Simacogo action. Check it out. Okay. Okay. Barely won that one. I've actually been back and forth, but here's a code, a creative type algorithm, successor function, evaluation function. It uses enum class for colors. Tuple to record my alpha beta information. Alpha beta node, not traditional node because it doesn't really have a pointer as everything else, just a kind of just a general object. Bunch of constructors, getters, and setters I use throughout my code. Here's the board class. Something I was done with first. Simple 9x9. Has your getters and setters. I just create the board, fill it full of blank spaces, and set the player to white. All it has is a board and a player. Get set player, get game board, set game board, clean board. Just some pretty your standard stuff. All I'm doing is just a whole bunch of looping, pretty much. Get board slot, set board slot, drop game piece. Pretty much just checks if the column is full, returns -1. If not, drops the piece and alternates the player. Here's the board is full. Check score condition, horizontal win +2. As you see, black counter, white counter, diagonal win, vertical, diagonal, all that. That's all that good stuff. Okay, and then then the game object itself just takes in an algorithm and a board. Asks if the board is full continuously, then I parse all that input. The only thing I don't do is parse for letters. That is something I don't have. Then basically try to drop the game piece. If it's -1, meaning that the row is full, then I'll just continuously ask the player to choose another row as you saw. Then it's time for the computer to go where it just runs the algorithm successor function, asks if the board is full, and tries to drop the game piece. This is mostly just for debugging, so the player would essentially never see that. And so I just print the board throughout, and then once the board is full, I check the score condition, and then just print the score. And this is just the main game loops, create a board, infinite loop. It just continuously, just plays the game. As you see, only takes in 1 and 2. If it's any other thing, then it's an invalid choice. Here's Minimax. Pretty much make sure the player is always black. Creates a copy of the board. Checks if any of the rows are full. And I essentially just drop a game piece up into my difficulty. I did it iteratively. And essentially just evaluate my board once I dropped it. Once I, kept dropping the pieces up to that difficulty, essentially just sort of running like a pseudo depth first search. And then, I run the calculations, just checking if, the rows that I'm dropping things in is full or not. And then I just essentially just grab the highest value and the highest column that I have of the calculations that I run that came from my eval function. That's here. And, I just return that path. The eval function just checks all my directions and just basically adds to a counter. Like if I'm next to a color, it adds 2. If I'm next to just a blank space, it only adds 1. And so naturally, the columns that have my same color will have a higher score. And so those are the ones that I choose. And yeah. And that's just from the whatchamacallit. And so alpha beta pruning, this is the one I actually had the most fun with. Even though it proved to be a little bit difficult because I didn't necessarily add in difficulty, but I still did this iteratively. I don't know why my brain went iterative and why I didn't go recursive. Shame on me, but eventually I'll get better with recursion. I just kind of my brain just kind of processes things in loops. And so I just create, all I do is just take in the board and the difficulty. And essentially I have a limit because I know that at most, the score can be 15, or at most they have 15 chances to score around where the piece is dropped. And so AB node array of states, I just essentially capture the state and I just go through the entire table, just looking for different colors and establishing different nodes for whether or not if it's blank or white space, if it's full, or if it's black space. And essentially after I do all that checking, right, I then get the alpha beta info. Or that was alpha beta info. Then I just that's all within the successor function. So essentially, I take in the board, run the get alpha beta info, fill up a state, and then essentially create a new board, drop all my pieces to do my depth first search, and then I create a state based off of that. And essentially, I'm doing a whole bunch of comparisons, looking for the one space that has the most points for me, and opportunities for me to score. That's pretty much it.